Okay.
Yeah, wonderful. Good. Yeah, I would like to talk about the environmental, social, and economic impacts of climate change with a focus on Europe. Now, Jean-Pascal van Ypersel gave a great presentation in the first session this morning on what is known about climate change globally and in Europe, building largely on the recent IPCC assessment report published last month. Now, for the impacts of climate change, they are covered in what is called the Working Group 2 of the IPCC, and that assessment will only come out in February next year. Of course, there are drafts and I've seen them, but they're confidential, so I will have to build on some mostly work by the European Environment Agency, which is, however, of course, informed and consistent with the EA reports. I will basically look at some selected sectors that are climate sensitive. Of course, I cannot go into detail of all sectors and impacts in this limited time, and then conclude with some cross-sectoral and economic impacts. Yeah, my presentation builds mostly, but not exclusively, on a number of recent EA reports and products. But of course, I'm also looking at other information sources, such as more recent IPCC reports, information from the Copernicus Climate Change Service, and other scientific publications. Here I added one slide, apologies for the interpreters, just to show again how Europe is affected differently by climate change. So what you see here at the left is the projected warming in Europe, where you see indeed warming everywhere, with some regional differentiation, and in particular the Arctic is projected to warm more than the rest. But the central and the right picture show the projected changes in precipitation. And here you see a clear differentiation. In the middle, the annual precipitation is, oops, I think you might, yeah. The annual precipitation is increasing in Central and Northern Europe. It is projected to decrease in the Mediterranean region. But if you look at summer, which is often particularly important for agriculture, for other activities, you see the zones shifting much more, so that all of Southern Europe and also parts of Central Western Europe experience a decrease in precipitation. And so this is really driving also different impacts in Europe, that for the precipitation, we have clear differences in what to expect, and we already see them. Now, in this report published around 4 years ago, we provided an overview on how climate change would affect different regions in Europe, the Arctic region, coastal zones, Mediterranean region, and so on. And so there are some impacts which are affecting almost all regions, whereas others are specific based on the climatic factors, on the environmental factors, on the structure of the economy, and so on. Now, let me start by looking into health. And this is an area where we've worked particularly strongly with a number of strategic partners in recent years. And just in March, we've published a briefing here together with the Lancet Countdown on Health and Climate Change on the health risks of climate change in Europe. You will find links to all publications and sites I mentioned here at the end of this presentation. And yes, heat is a key factor. Heat is a killer, sometimes a silent killer in Europe, but there are many more effects. So it's not just heat waves, it's floods, it's droughts, it's fire, it's extreme events affecting health infrastructure, affecting also the health of those working in hospitals. And here you would even see a combination of effects with the COVID pandemic. Obviously, those who medical professionals have to wear personal protective equipment have even more difficulties during a heat wave if the hospital is not appropriately climatized, and so on. So there are a number of effects how climate change can affect health. And this is basically repeating in an overview what Jean-Pascal was showing earlier, that the main killer, if I may say so, of climate change are really heat waves in Europe. So out of those more than 90,000 fatalities measured in the last about 40 years, the large majority is really attributed to heat waves. And here the 2003 heat wave mentioned earlier is really standing out with around 70,000 attributed deaths. The good news here is actually that similar heat wave have impacted Europe earlier with much lower health impacts. So the introduction of heat health action plans was able to significantly reduce the health burden here in later events. Still, and this is another overview here, depending on the country, about 40%, 30 to 40%, sometimes even 50% of the heat related mortality in Europe can be attributed to human-induced climate change. So it is us, climate change, who is responsible for an increasing number of the heat-related deaths in Europe. And this is, of course, linked to the increase in summer temperature over the last 40 years that you can see in the right. These are measured temperatures, not predictions. Looking at briefly at the working environment, obviously, increasing heat threatens labor capacity, it threatens occupational health. This is an indicator from the Lancet countdown showing again how the exposure and the potential hours of labor lost are increasing. If you wonder why the agricultural curves shows significant variation but not such a strong increase, here the effect is because this also looks at the total number. And here we see a decline of agricultural workforce. So per worker, there's also an increasing potential of hours of labor lost in agriculture. Yeah, we've already seen pictures of the floods affecting parts of Western Europe just 1 to 2 months ago. It is clear that such events have massive health impacts, killing about 200 people, and many more suffer from injuries, and also, of course, the mental health impact in the regions is enormous. It also raises questions how to rebuild. If you look at the picture on the bottom left, you see the same region under normal conditions, under flood conditions. So there are massive questions whether it actually makes sense to rebuild in these regions. And just in Germany alone, a reconstruction fund of 30 billion euros has been created because of those floods. What is also quite important, and that's linked to the previous presentation, that the heavy rainfall, which led to these severe flooding events in Western Europe, was made significantly more likely by climate change. Of course, it is an extreme event, even in the current climate, but the likelihood of such events has increased significantly. This is called attribution studies in climate science. Just briefly on a number of other effects, also a number of infectious diseases, traditionally called tropical diseases. Some of them are spread or made more likely due to climate change. Vibrio infections, that's a seaborne infection, are increasing together with warming sea surface temperatures. This is particularly relevant for the Baltic Sea region and for some coastal regions with brackish waters. Also other health hazards such as algal blooms, in particular in the Baltic Sea, are linked to this, with further impacts on tourism and so on. And in the bottom you see, as an example, West Nile fever, how it is, where it is currently observed and where it is projected to be viable in the future. And this is West Nile fever, not West Rhine fever. Looking at another sector, the energy sector, Once again, there's no time to look at all those slides here or to look at all those impacts in this presentation, but I understand the slides will be shared. Maybe the take-home message is that all parts, all components of the energy system are vulnerable to climate change and extreme weather events, but the impacts of climate change are differing. They differ across regions, north, south, west, east, but also along energy sector components. So in some regions you see a green sign. So for example, hydropower in Northern Europe probably benefits from climate change, whereas if you look at Southern Europe, it's clear that this region is most adversely affected by a combination of decreasing water availability, increased peak electricity demand during heat waves, and so on. Maybe also just as an example here, climate change is a long-term process, and you see here the time scale from seconds to decades, but and those long-term changes are shown here on the right. Long-term temperature increase, precipitation changes, sea level rise, but they have impacts on weather phenomena even at the second and at minute scale. So the likelihood for lightning is changing, for thunderstorms, how pressure systems are moving, whether they stay longer in one region, and so on. So a comprehensive adaptation strategy needs to look at all those elements and how they are possibly affected in terms of building a resilient energy system. And of course, it's not only electricity production or energy production and transport that's affected. It's also the demand, and here in particular the heating and cooling demand. On the left, you see how the heating demand is decreasing all over Europe, of course, in particular in those regions with a high energy demand at the moment, but also how the cooling demand is increasing, which of course has effects on energy demand, but also how we build infrastructure, how we design buildings with a lifetime of sometimes 100 years that function well under current as well as future climate conditions. The question of refurbishing existing buildings is very important here. Yeah, without going into further, let's say, scientific details, just some images to show how extreme climate events are affecting, in this case, rail transport. These are all images from Europe, from the UK, from Germany, from Switzerland, showing the sometimes catastrophic impacts of extreme weather events combined with sea level rise for the coastal infrastructure on rail transport. Also just some images to illustrate the case for road transport. And yes, what you see on the left, it is not a river normally, this is a motorway. Very clearly, agriculture is affected by climate change. It's very climate sensitive, depending on temperature, on precipitation, but also on wind, on late frost, and a number of other factors. Once again, the impacts differ, but all regions are affected. And also here for agriculture, we see a pattern that we see in a number of other factors, that the regions in Southern Europe are more negatively affected in general than the ones in Northern Europe, where there are also some beneficial effects. This is one example to illustrate this. Here you see on the left in red and yellow the strength of a summer, or actually was a spring and summer drought in 2018, which affected large parts of Europe. And then on the in the center and right, you saw how the yields of here two grains, wheat and barley, were affected by this. So the regions where the drought was particularly strong clearly showed a decrease in yields, and the same could be shown for other crops, and this has effects on the producers, but of course also on the consumers in terms of price changes. Once again, this is a look backwards, comparing the agroclimatic zones, like the zones where climate factors allow growing a particular type of crops, how they have shifted. And the difference here is just 20 years. So this is a period towards the end of the last century, on the right, like the earlier part of this century. And of course, there has not been a complete restructuring, but you can already see shifting of zones, and this will only further increase, raising a number of questions on the viability of agriculture in some of those regions. Now, this is an attempt to actually translate those changes projected for the future in a particular economic analysis. So what would happen if climate change affected, let's say, the current agricultural system instantaneously, and how would that affect farmland value? And here you see the regional pattern very strongly of extreme negative effects in parts of Southern Europe, and some beneficial effects in the north, however, mostly in regions with a low population density. Now here I have to stress that this analysis assumes basically the current system, so adaptation measures that would certainly occur are not considered here, but it nevertheless shows the size of the problem, because there are also limits to adaptation. If you think of irrigation, you do need water. Where does it come from? What are the competing uses? If you wish to assign water to agriculture, these are already existing challenges, for example, in Spain and other Southern European regions. Just very briefly on ecosystems, natural ecosystem here, it's a bit harder to come up with, let's say, simple numeric values. It's just to illustrate that ecosystems are responding to climate change. So this is something you can see in a slightly complicated graph on the left, how in this case bird and butterfly communities are changing their composition, with more species that are, let's say, accustomed to a warmer climate and less that are accustomed to a colder climate. And the apologies again for a slightly more complex graph on the right. You see that the adaptation is not fast enough, it's not sufficient. Here it shows how two, let's say, groups of bird species have changed in Europe, and this is a slightly outdated figure, but the trend is nevertheless clear. The yellow curve shows bird species that you would expect to respond positively to regional climate change. So the warm-loving species, they've done well, whereas across Europe, the more cold-loving species show a declining trend. And this is continuing over time. So some adaptation occurs, but it cannot happen fast enough. Even though birds can fly, they rely on insects, they rely on trees, on plants also changing their annual cycles, and that cannot happen fast enough in many cases. It was also mentioned fires, forest fires, wildfires. They're a great threat for the ecosystems themselves, but of course also for population living in the vicinity. And across Europe, the weather-driven fire danger has been increasing and will be increasing further. And we saw some catastrophic wildfires in Greece this year, but also in Portugal a few years ago, with also tragic loss of life. Now, to bring things together and to summarize, extreme climate-related events are already costly. On the left, you see how this is distributed across different categories here. Floods and storms are responsible for more than half of the economic damages. Heat waves are not quite as costly in terms of the economic impacts, but can be quite costly in terms of lives, as we have seen earlier. And if you look at the central pie, these are the insured losses. So here you see quite some difference, that some impacts are better insured than others. But if you look across Europe, only a third of those impacts are actually insured, and the rest sits with those people directly affected. And on the right, you can see various figures how those impacts are distributed across countries in Europe. To summarize, all regions in Europe are and will be affected by climate change, but there's a varying regional pattern. So this analysis tries to look at different sectors of the economy, of the society, and simply compares how many of them are positively affected, how many are negatively affected. So if you look at the potential winners, and this is in quotation marks because it's a very simplified analysis, you see them mostly in the colder regions in Northern Europe, to some degree, maybe in mountain regions. Whereas if you look at those regions where different sectors are negatively affected, you see more of a concentration in Southern Europe. And just to conclude, climate change impacts in Europe are affecting us, but Europe is also vulnerable to climate change impacts outside Europe through trade, through infrastructure risks, through geopolitical risks, conflicts, potential migration, and also the financial links to other regions of the world. So even if a weather-related disaster affects a region outside Europe, we can be directly affected by that in many ways. Here are the links to a number of relevant EA products, and I'm very happy to take questions. Thank you.